Welcome to Two Projects. In this video, we are going to explain the project Integrated Multiscale Domain Adaptive YOLO. Introduction. Convolutional neural networks CNNs have demonstrated remarkable success in object detection, yet they face a critical challenge known as domain shift. This occurs when testing data differs significantly from the training data, leading to performance degradation. Factors such as varying weather conditions or viewpoints can cause this shift, impacting the reliability of object detection models. So, the project focuses on addressing the domain shift problem, particularly in the context of object detection using YOLO based architectures. Under domain shift, models trained on specific conditions struggle when applied to diverse environments, and the lack of annotated data for the target domain exacerbates this issue. Therefore, the project emphasizes the need for domain adaptation techniques to enhance the adaptability of YOLO based object detection methods. The significance of the project lies in its contribution to the field of domain adaptation for object detection. With a primary focus on YOLO based architectures, which have received limited attention in domain adaptation research, the project aims to improve the robustness of these models. By addressing the challenges posed by domain shift, the project seeks to enhance the generalization capabilities of YOLO based object detectors across diverse scenarios. So, the project proposes a solution leveraging domain adaptation techniques tailored for YOLO based architectures. By incorporating strategies to generate domain invariant features, the goal is to mitigate the impact of domain shift on object detection performance. And the beneficiaries of this project extend to various domains, including autonomous vehicles, surveillance, and image analysis, where reliable object detection under diverse conditions is crucial for ensuring the safety and efficiency of systems. Ultimately, the project aims to contribute to the development of more robust and adaptable object detection models with broader real world applicability. Objective of the project. So, as I already mentioned, the project's first goal is the deployment and implementation of YOLO V4, an advanced object detection model. So, the goal is to train and fine tune the YOLO V4 model on specific datasets, ensuring efficient and scalable model development. And the project seeks to enhance YOLO V4's capabilities by integrating MCDA YOLO, that is, modified YOLO for domain adaptation. It is a proposed modification specifically designed for effective domain adaptation. This involves understanding and implementing MCDA YOLO's mechanisms that address the challenges posed by domain shift, enabling the model to exhibit robust performance across diverse testing scenarios. And the final objective involves systematically evaluating the performance of both YOLO V4 and MCDA YOLO. This evaluation includes assessing their accuracy, precision, and recall on datasets that represent different domains. Through comparative analysis, the project aims to showcase the effectiveness of MCDA YOLO in mitigating the impact of domain shift, emphasizing its potential to enhance object detection performance in varied real world environments. Requirements needed to execute this project are software requirements. Software needed is Anaconda, primary language used is Python, front-end framework used is Flask, back-end framework used is Jupyter Notebook, database used is SQLite 3, and front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll discuss the working modules of law of work. So the first step is importing required packages. So the initial step involves importing essential packages such as NumPy, Pandas, Matplotlib, Sklearn, TensorFlow, and Keras. These form the foundational tools for data manipulation, visualization, and machine learning, creating a robust environment for subsequent tasks. The second step is exploring the dataset. So, the dataset exploration phase encompasses reading and plotting images to gain an understanding of the data. The third step is image pre processing. So, this step involves pre processing images, including converting them to blob objects, defining classes, declaring bounding boxes, and converting arrays to NumPy arrays. These processes prepare the images for subsequent stages in the computer vision pipeline. The next step is loading the pre-trained model. Here, the pre-trained model is loaded and its network layers are read. Output layers are extracted, setting the stage for utilizing the pre-trained model for object detection tasks. The next step is image processing again. So, further image processing involves appending image annotation files, converting color spaces, creating masks, and resizing images. These steps ensure compatibility and optimization for the subsequent phases. The next step is data augmentation. In this step, data augmentation techniques such as randomizing, rotating, and transforming images are applied. These augmentations enhance the model's ability to generalize and improve its performance on diverse datasets. The next one is installing the packages required for YOLO v5 in Colab. Here, the necessary packages for implementing YOLO v5 in Google Colab are installed, ensuring a seamless integration of the YOLO model for subsequent data processing and training. The next step is processing the data based on YOLO v5 model. So, the dataset is processed in alignment with the YOLO v5 model requirements in this step. This includes organizing and formatting the data to match the model's expectations, ensuring optimal training performance. The next step is training and building the models. In this step, YOLO models, including YOLO v4, MCDA YOLO, are trained and built. This involves fine tuning the models on the specific dataset to improve object detection capabilities. And in the next step, as an extension, exploration of additional models such as YOLO v5, x6, and v8 is conducted, aiming to enhance the robustness and accuracy of the final predictions beyond the initial set of models. And as an extension, again, a front end interface is constructed using the Flask framework, incorporating SQLite for sign up and sign in functionalities. This user friendly interface allows users to input images, triggering pre processing and detection using the trained models. So, after signing in, users input images through the front end, initiating the model detection process. So, the given inputs undergo pre processing, and the pre processed images are fed to trained models, and the model infers and detects objects, applying segmentation and bounding boxes to identify and distinguish each object within the input images. And annotated images showcasing detected objects with bounding boxes are displayed through the front end interface, providing users with a visual representation of the model's predictions. Now we'll understand about the algorithms used. So the first algorithm built is YOLO v4, that is YOLO Look Once version 4. So YOLO v4 is an advanced object detection algorithm designed to identify and locate objects within images or video frames. The uniqueness of YOLO lies in its single shot detection approach, dividing the input image into a grid and predicting bounding boxes and class probabilities directly. This enables YOLO v4 to achieve both high speed and accuracy, making it particularly well suited for real time applications. The algorithm involves grid division, bounding box prediction, class assignment, and the application of non maximum suppression to filter redundant predictions, ensuring efficient and precise object detection. The next algorithm built is MCDA YOLO, that is modified YOLO for domain adaptation. So, MCDA YOLO is a tailored modification of the YOLO v4 architecture aimed at addressing the challenges posed by domain shift. In the context of object detection, domain shift occurs when testing data differs significantly from the training data, impacting model performance. MCDA YOLO introduces specific mechanisms to make YOLO more robust in diverse testing environments. It focuses on generating domain invariant features and incorporates adaptation strategies to mitigate the impact of domain shift on object detection performance. By doing so, MCDA YOLO enhances the adaptability of YOLO based models to a variety of real world scenarios. Now we'll see the comparison graphs. So, this is the horizontal bar graph comparing precision scores of different algorithms. In this graph on x axis, I have precision scores, and on y axis, I have algorithm names. So, precision measures the accuracy of positive predictions, representing the ratio of true positives to the sum of true positives and false positives. This is recall scores comparison graph. In this graph on x axis, I have recall scores, and on y axis, I have algorithm names. So, recall assesses the model's ability to capture relevant instances, calculated as the ratio of true positives to true positives and false negatives. And this is MAP scores comparison graph. In this graph on x-axis, I have MAP scores and on y-axis I have algorithm names. So MAP, that is mean average precision, evaluates object detection performance by calculating the average precision for each class and then determining the mean over all classes. So the algorithm which is best performing in all the performance metrics will be used for detections. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is data folder in which I have required images dataset on which we will train and test the models. This is sample folder in which I have images on which we will make the detections. This is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. And these are model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. This is Jupyter source file in which I have a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. So this file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it and open Anaconda prompt. So use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, local host and port unless configured differently. So this is the local host and this is the port. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link. Click on it. So if we are new users, we have to register first. Fill in all these details and click on submit button to register. And if we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. So here we have to provide a credentials, username and password and click on submit button. So it has redirected us to the detection page. So here we have to upload an image and the application will detect the objects in the image. Click on choose file button. So from sample images folder, I'm selecting this image and click on open. So the image is loaded. Now click on upload button. So we can see the application has detected the objects. It has drawn bounding boxes around the detected objects. So we can see it has detected truck, it has detected the cars, and it has detected the traffic light. It has denoted these different objects with different colors. And we can also see a probability score here telling us how confident the application is about the detections. Now click on back. We'll try giving another image. Click on choose file button. This time I'm uploading this image and click on open. So the image is loaded. Now click on upload button. So we can see the application has detected the object. It has drawn the bounding box around the detected object. It has classified the detected object as car. and we can see the probability score here telling us the confidence level of the detection. Similarly, we can upload any image and can get the detections. Click on choose file button. So this time I'm uploading this image and click on open. The image is loaded. Now click on upload button. So we can see the application has detected truck and the bus. Click on back. Click on choose file button. So I'm uploading this one and click on open. The image is loaded. Now click on upload button. So we can see the application has detected the cars and the truck. It has differentiated them with two different colored bounding boxes. Click on back and click on sign out. So the conclusion here is the project has contributed to the evolving landscape of object detection by implementing and enhancing YOLO V4, a cutting edge algorithm known for its efficiency and accuracy. The integration of MCDA YOLO into the YOLO V4 architecture showcases the project's dedication to addressing the critical challenge of domain shift. By introducing domain invariant features and adaptation mechanisms, MCDA YOLO aims to make object detection models more robust when applied to diverse testing scenarios. And the extensions of the project by considering the integration of advanced YOLO versions like YOLO V5X6 and YOLO V8 offer enhanced features and capabilities, further pushing the boundaries of object detection. In addition to model development, the project explores Flask integration, facilitating the seamless deployment of the developed YOLO V4 and MCDA YOLO models. The integration with Flask enhances the accessibility of the models, providing a user friendly interface for practical implementation and widespread adoption. So, the project's contributions extend to various domains, including autonomous vehicles, surveillance, and image analysis, where reliable object detection under diverse conditions is crucial. The developed models hold promise for improving safety and efficiency in these domains.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.